Okay, so today we're going to be talking about something that I think is really important, especially if you're aiming for, one of those senior software engineer roles.
Yeah,
Whoa.
absolutely.
System design comes up a lot.
It really does. It's a big part of those senior level interviews.
And one of the things that you always have to think about with system design is how your system's going to handle, like data, lots of data.
Yeah, especially as the system grows and changes, right? I mean, you're not just designing for the day one launch. You're designing for how that system is going to evolve over time.
Absolutely. Yeah. It's like, version 2, version 3, version 4 down the line. How is all that data going to play nicely together?
Right, exactly.
And, we see a lot of questions and discussions around this in the community. So we're going to kind of zero in on one specific problem that I think is kind of sneaky. It can catch people off guard.
Yeah, it's a bit of a hidden trap.
And it has to do with, when you have different versions of your application that are all trying to work with the same database.
Yeah, I see what you mean. So you have like multiple versions of your app out in the wild, maybe because you're doing rolling deployments or maybe you have different instances running for scalability or fault tolerance,
Right, exactly.
and they're all hitting the same database.
And then things get messy.
Yeah, you could definitely run into compatibility issues there, especially when it comes to your data.
Yeah, that's the scary part, right? It's like it's your data. You can't afford to lose that.
No, absolutely not. And that's what makes this topic so interesting. It's not just a theoretical problem. It has real-world consequences.
Okay, so before we get into the really the nitty-gritty here, I think it's helpful to just take a step back and think about how our applications interact with the database on a basic level.
Sure.
We're constantly writing data to the database and we're constantly reading it back.
Right. It's all about reading and writing data. That's the core of it.
And whenever we do that, we're essentially encoding and decoding data.
Exactly. Like when your application writes data, it's putting it into a format that the database understands.
Mhm.
And when it reads the data back, it's taking that database format and converting it back into something that the application can work with.
Right. And as long as you're dealing with a single consistent version of your application, that whole encoding and decoding process usually isn't too much of a headache.
Right. Yeah. You have full control over both sides of the equation. You know how you wrote the data and you know how you're going to read it back. It's like a conversation with yourself.
But then you introduce, like we were saying, you introduce multiple versions.
Right. And that's where things get interesting.
And one of the fundamental ideas here is this concept of backward compatibility.
Right. So backward compatibility means that a newer version of your application can still read data that was written by an older version.
Right. Like it can still understand that data format, even if the new version has maybe made some changes to the way it stores things.
Exactly. Like think about it this way. When your application writes data, it's essentially creating a record for its future self, or potentially another version of itself down the line.
Mm-hmm.
For everything to run smoothly, that future version needs to be able to understand the data format that the current version used.
Oh, that's a good way to put it. Yeah.
It's all about being able to read those old records and understand what they mean.
Okay, so backward compatibility is pretty intuitive. We want our new versions to be able to understand the old stuff.
Right, yeah. You don't want to break things when you release an update.
But there's also this other concept called forward compatibility,
Ah, yes.
which is a little less obvious.
It's a bit more subtle, yeah.
Yeah.
So forward compatibility is about whether an older version of your application can still interact with data that was written by a newer version.
Right. Can it handle data that has new elements that it wasn't originally designed for?
Exactly.
Yeah.
Can it read that data? And importantly, can it modify that data and write it back without breaking things?
Okay, and I think this is where we start to see some of those tricky situations pop up.
Yeah, this is where things can get a bit messy.
So let's imagine a scenario.
Okay.
We've got, we have a way to store information about like a person,
Okay.
right? So like maybe in our database we have a person record.
Right.
And initially, we're tracking their username,
Okay. Makes sense.
their favorite number,
Right.
and maybe a list of their interests.
Okay. So pretty basic profile information.
Yeah. And then, time goes by and we decide, we're going to roll out a new version of our app.
Hmm.
And we realized, hey, it would be really cool if we also stored a photo URL for each person.
Yeah, add a profile picture. That's a pretty common feature request.
So our new version of the app starts writing data that includes this new photo URL field. But now picture this, right? We've got an older instance of the application, maybe one that's still running on, somebody's phone or somewhere.
Right, an older version that hasn't been updated yet.
Exactly, yeah. And this older version, it knows nothing about this photo URL field.
Right, it was built before that feature was even a thing.
So it reads in the data from the database for a person,
Okay.
and it sees the username, the favorite number, the interests.
All the fields it expects to see.
Right. But then there's this extra field, this photo URL field, which is just kind of like, it's just there. It doesn't know what to do with it.
Right, it's like an unexpected guest at a party.
And now let's say, the user decides they want to update their favorite number.
Okay, so they go into the app, they change their favorite number.
Yeah.
And the older version of the app does its job.
Mm.
It modifies that number in the data read from the database.
Right.
And then what does it do? It writes that data back to the database.
Exactly. It writes it back. But here's the kicker. Because this older version doesn't know anything about the photo URL, it doesn't include it when it writes the data back.
Ah, I see where you're going with this.
Yeah.
So that photo URL that the newer version carefully saved, it's gone. Poof. Vanished.
Yeah. Data loss. Just like that.
And that's the sneaky part about this problem. It can happen silently without any errors or warnings.
Yeah, the application doesn't necessarily crash. It just kind of, it blithely goes on its way.
And you might not even realize the data is missing until much later.
Right, right. And the scary thing is that the way the data is actually stored in the database might be perfectly capable of, holding on to that extra photo URL.
Yeah, you're right. A lot of modern data encoding formats are actually designed to be extensible. They allow readers to skip over data they don't recognize.
Like they can just kind of, jump over it.
Exactly. So the database itself might not be the problem here.
It's the application logic.
It's how the application handles the data.
Yeah, so when the application reads the data and it tries to fit it into its own internal model, like maybe a person object or something like that, if that model doesn't have a slot for photo URL,
It's going to get lost in translation.
yeah, it's like, it's like if I'm reading a book and there's a sentence in a language I don't understand,
Yep.
I'm just going to kind of skip over it.
Right. You're not going to try to translate it or interpret it.
And then if I'm, making a copy of the book, I'm just going to leave that sentence out.
Exactly. It's not malicious. It's just you don't know what to do with it, so you leave it out.
So that's kind of what's happening here with the application kind of.
Right, right. And this really emphasizes the importance of being aware of this potential for data loss.
Yeah, yeah. I mean, especially at the senior level.
Yeah, this is the kind of thing that senior engineers need to be thinking about proactively.
Because they're responsible for designing systems that are robust, that can handle these kinds of changes.
Right. They need to be thinking about the long-term implications of their design decisions.
And one thing that's really, I think, important to keep in mind here is that data often has a much longer lifespan than code.
Oh, absolutely. You might be deploying new versions of your application every week or every month.
Mm-hmm.
But the data sitting in your database could have been created months or even years ago by different versions of your application, each with their own idea of what the data should look like.
Right. You have this historical diversity in your database.
Exactly. And that can be a real challenge to manage.
And it wouldn't be practical to try to, rewrite all that existing data every time you make a change to your data model.
No, that would be incredibly expensive and time-consuming.
Yeah. So databases often try to, accommodate these changes to the data structure without requiring like a complete overhaul of all the existing data.
Right. They try to make it possible to evolve the structure without having to go back and update every single existing record.
Right. Like, in a relational database,
Mm-hmm.
you can add a new column to a table and set a default value for it.
Right, like a null value or something.
Yeah. And then all the existing rows that were created before that column existed, they'll just have, null in that field when they're read.
Exactly. It's a way to fill in the gaps without rewriting the entire database.
Yeah. And some database systems are even more specifically designed with this idea of schema evolution in mind.
Oh, yeah, absolutely.
Excellent.
They have built-in mechanisms for handling these types of changes gracefully.
I was reading a bit about espresso.
Espresso. Oh, yeah. That's LinkedIn's document database.
Yeah.
I've heard good things about it.
And they use Avro for their data storage.
Ah, Avro. Yeah.
And Avro is interesting because it actually embeds the schema of the data within the data itself.
It does, yeah.
Yeah.
Which is really clever.
Which I think helps a lot with managing, these different versions.
Oh, absolutely. Avro's design is all about schema evolution. It provides a set of rules for how systems with different versions of the schema can still effectively communicate.
Right.
Like, how to handle missing fields, how to handle data type changes, things like that.
Yeah, it's pretty neat.
It's a very powerful system.
And it can really help prevent the kind of silent data loss that we were talking about before.
Yeah, because with Avro, the older version of the application would actually be able to see that there's this new photo URL field, even if it doesn't know what to do with it.
Right.
And at least it could preserve that data when it writes back to the database.
Okay. So we've been talking about, data in our primary application, but what about when we're, maybe archiving older data or loading it into like a data warehouse for analysis?
Yeah, good question. Does schema evolution come into play there as well?
Yeah.
Absolutely. In fact, it might be even more important in those scenarios.
Interesting. Why is that?
Well, think about it. When you're archiving data or loading it into a data warehouse, you're often taking a snapshot of your operational database at a particular point in time.
Right.
And you want to make sure that all that data is consistently encoded using the latest version of the schema.
Right. Because you're moving it or copying it anyway, you might as well, bring it all up to date.
Exactly. And formats like Avro object container files are really well suited for this kind of thing.
Oh, okay. Yeah, because Avro is, it's designed to be self-describing.
It is, yeah.
Yeah.
So you can easily take an Avro file and load it into a different system without having to worry too much about schema compatibility issues.
Right. And, if you're doing data warehousing, you might even transform the data into a columnar format like Parquet.
Ah, Parquet, yeah. That's a great choice for analytical queries.
Yeah.
And it often handles schema evolution in its own way, too.
Okay, cool. So I think, for anyone out there who's getting ready for those senior software engineer interviews, this whole area of schema evolution is really worth, digging into.
Oh, yeah, absolutely. It's a topic that interviewers love to ask about.
Yeah. Because when you're talking about system design, they're looking to see that you're thinking about the long term.
Right. They want to see that you're not just focused on getting the system up and running,
Right.
but that you're also thinking about how it's going to be maintained and evolved over time.
Yeah, and how it's going to handle, like those inevitable changes to the data model.
Exactly. So being able to demonstrate an understanding of the challenges of schema evolution is a big plus.
Yeah. So, like, if I'm in an interview and I'm describing a system that involves, data storage,
Mm-hmm.
it would be a good idea to, proactively mention the need to think about, both backward compatibility and forward compatibility.
Oh, yeah, for sure.
Yeah.
You want to show the interviewer that you're thinking ahead?
Right. What happens if the data structure changes down the road?
Exactly. You're not just designing for today, you're designing for the future.
And, you could even mention some of the potential pitfalls, like the scenario we walked through where, older applications can inadvertently cause data loss.
Right. Especially if they're not designed to handle unexpected fields gracefully.
Yeah. And, I think knowing about some of the different data encoding formats that have built-in mechanisms for handling schema evolution, like Avro,
Mm-hmm.
that could be a valuable thing to bring up as well.
Oh, yeah, definitely.
Especially if it's, relevant to the type of system that you're discussing.
It shows that you're familiar with the tools and technologies that are available.
Right. And that you're thinking about, how to actually implement these ideas.
Yeah, it's one thing to talk about schema evolution in the abstract. It's another thing to be able to talk about how you would actually handle it in a real-world system.
Okay, so big takeaway, I think, is that you can't just treat your data model as, like a static thing.
No, absolutely not. Data models evolve, they change, they grow.
Yeah, and you need to design your applications and your data storage with that evolution in mind.
Right. You need to be thinking about how to make your systems robust and resilient to these kinds of changes.
Yeah. And I think that phrase that we mentioned earlier, ignore on read, preserve on write.
Ah, yes.
That seems really crucial here.
It's a good rule of thumb, yeah.
Like, if an application encounters a field that it doesn't understand, it should just, leave it alone.
Right. Don't try to modify it. Don't try to delete it. Just leave it as is.
Yeah, it's not your problem to solve.
Exactly.
And that can help prevent a lot of headaches down the road.
It can, yeah.
Okay, so as we're kind of wrapping things up here, um, this whole idea of schema evolution and data compatibility,
Yeah.
I think it's only going to become more important as systems become more complex.
Oh, absolutely. With microservices and distributed architectures becoming more and more popular,
Right.
the potential for these kinds of data compatibility issues, it just multiplies.
Yeah.
You have all these different services talking to each other, sharing data.
Right.
It's a recipe for headaches if you're not careful.
Yeah, it definitely gives you a lot to think about. And who knows what other kind of unforeseen challenges might arise from like, all these different parts of the system interacting with each other.
Yeah, it's a fascinating area. And it's one that's going to continue to evolve as our systems become more and more complex.
Yeah, I have a feeling we'll be talking about this again. But that's all the time we have for today. Thanks for joining me.
It was a great discussion. Thanks for having me.
And for everyone listening out there, keep those questions coming, and we'll see you next time.